Welcome back to another exciting chemistry lesson. Well, in the previous lessons, we learned about ions and how atoms lose or gain electrons to become ions. Now, in this lesson, we are going to look at how ions that are oppositely charged would form compounds. And here are the steps to determine what compound are made from the two ions. Well, the first thing is first, always place the positive ions first. There's a saying, always be positive. If you can't remember positive or negative, think of the statement, always be positive. So positive ion first. And that, here's a little trick, okay? You have to combine the total positive and the total negative charges to be equal to 0. And I'm going to explain this a little bit more. But the strategy is to use the least common multiple of the two numbers of the positive and the negative charges. But before we do that, let's look at this part. We have this compounds right here, okay? Well, we have magnesium nitrite. Well, here we have magnesium ions. We know that's in group 2A, and that's Mg2+, okay? And we know that nitrite, right? Well, nitrite is NO2-. And look what we have. We have 2 of the nitrite. So we are going to interpret ionic compound. So in this case, this compound consists of how many magnesium ions? Just 1. So 1 magnesium ions has a charge of 2+. So the total positive charge in this case is 2 positive. It also consists of nitrite ions. How many? Well, that tells you there are 2 of nitrite ions. Well, if there are 2 of them, the total negative is what? Is 2 minus, because right here we're talking about 2 times 1 minus, of course, give you -2. And look at step 2. We have a total of 2+ and a total 2 minus. That cancel out, right? You add them together, that cancel out, equal to 0. So the net charge, hence the term total charge of positive negative, is 0. And that is the purpose of ions making compound. So their net charge is equal to 0, and they give you the stability as an ions function together in a compound. Let's try another one. We have magnesium fluoride. Well, magnesium ions is right here. How many do we have? Well, we just have 1. Okay? And the total positive charge of magnesium is, if I don't remember what is magnesium charge going to be, I can always look at fluoride. Remember, fluoride is F-, and there are 2 of them. If we multiply by that by 2, that's 2-, right? So this one must be 2+. So here we have 2+. But if you don't remember, go back to your periodic table. Magnesium is in group 2A, therefore it has a charge of 2+. Then it also consists of 2 fluoride ions. So we have 2 fluoride ions. In this case, the total negative is 2-. And the same thing again, we have 2+ plus 2-. The sum of the positive, right, and the negative is equal to 0. Hence, the net charge is 0. Now, let's go back to this concept where we have to find the least common multiple of 2 numbers to figure out how many of the negative ions or the positive ions that we need. Let's look at this one right here. Notice how this is the charges, okay? We have 2 and 1+. So think of the number 2 and 1. What is the common multiple? Well, look at multiple of 2. 2, 4. For 1, it's 1, 2, 3. So what is the common multiple? Well, it's 2. First thing first, is this in the right order? No, it has to be positive first. So we're going to rewrite this. Okay, we have NH4+ and S2-. So if I have 1 times what will give me 2? Well, 1 times 2 give me 2. In this case, I will have 2 of this. So our answer is going to be NH4, 2 for this positive side. And then this 2 right here, 2 times what will give me 2? Well, 2 times 1. Now remember about the number 1. If it is just 1, we can ignore it. We don't have to write it. So therefore, we just have S. And this is the compound that these 2 ions will make. And of course, if you are to type this on Streamline Ed, you just type this normally, okay? Just ignore trying to make the number a subscript or superscript. Let's try another problem. Here we have oxygen, or specifically oxide, O2 minus, and then we have aluminum, Al3 plus. Is this in the right order? No. We have to go back and rewrite it. So right there we have Al3 plus, okay, and we have O2 minus. And we notice the number 3 and 2. What are the common multiple of 3 and 2? Well, look at this. 3, again, let's just write it down. 3 times 1 is what? It's 3. 3 times 2 is what? Is 6. Now, well, let's look at 2. We have 2 times 1 is 2. 2 times 2 is 4. 2 times 3 equal to 6. Oh, look, the common or the least common multiple is 6. Now, let's go back and look at this. 3 times what will give you 6? Well, 3 times 2 give you 6. So that tells you right there, 3 times 2 give you 6. That means there are 2 of Al plus. And as you write your compound, we don't write down the charges anymore. Okay? We already know the charge is going to be 3 plus. What about for oxygen? 2 times what will give you 6? So again, the least common multiple is 6. Well, 2 times 3 is 6. Therefore, we are going to have 3 oxygen. And that is how we use the least common multiple to determine how many of the positive ions and how many of the negative ions that we need to make a neutral compound. And to prove that to you, 2 aluminum 3 plus, Al3 plus, that gives us a total of what? That gives us a total of 6 plus. For oxygen is 2 minus, and there are 3 of them, 2 minus, and 2 minus. That gives us a total of what? 6 minus. What's 6 minus and 6 plus? That turned out to equal to 0. Let's try another problem. Here we have sodium hydroxide. Well, is this in the right order? Yes, because the positive is first. Now look at this. We have 1 plus and 1 minus, because you only see the positive and negative. Well, in this case, the charge already cancel out each other already. So our answer is just going to be NaOH. 1 of each. Isn't that easy? Let's try the last problem. Here we have nitrate and calcium. Nitrate is this one, calcium is this one. Are they in the right order? Remember, always be positive first. So we have calcium, 2 plus, and nitrate, NO3 minus. Now, let's look at this. That is number 1 right in front of the minus sign right there, right? So what's the least common multiple between 2 and 1? For the number 2, it's 2 times 1 equal to 2, and then 2 times 2 equal to 4. And then for the number 1, here are the multiple of 1. 1 times 1 gives you 1. 1 times 2 gives you 2. Oh, look at that. Here we have our least common multiple. So our least common multiple is 2. So 2 right here for calcium. 2 times 1 will give you 2. Well, of course, just 2 times 1. So we just have 1 calcium. And of course, we don't have to write the 1. But for the nitrate, 1 times what will give you 2? In this case, 1 times 2 give you 2. So we have 2 of this whole entire thing. So we have NO3, 2. And notice how we need the parentheses, right? That's because this is a polyatomic ions. The same thing here for ammonium. There are 2 of ammonium, or NH4. We need the parenthesis to indicate there are 2 of the whole entire thing. But for aluminum, look what the mistake I did. Aluminum, you don't have to worry about this at all. You don't need parentheses at all. So in this case, just aluminum Al2. That's it. And that's how you determine a compound from 2 oppositely charged ions.